This is 5.3, Solving Systems of Linear Equations by Elimination, Part 2. So yesterday, or in Part 1, we were looking at how to solve them by elimination. So today we will be incorporating step 1, which means that we will have to multiply one of the equations or both of the equations by a constant to make a match. So in this first example, if I have x minus 3y equals 24 and 3x plus y equals 12, I don't initially have a match, so I'm going to take my first equation and multiply it by 3 to make a match. So then I will multiply by 3, and I will get 3x minus 9y equals 72. Now I see I have a match in the x's, and so I'm going to subtract them so that the x's will be eliminated. So I get 0, and then 1 minus negative 9 is adding, so I get 10y equals negative 60. Then solve for y, and y equals 6. I can plug this back into one of my equations. Equation 1 looks a little simpler. So take my y and plug it in, and then solve for x, and x equals 6. So my answer is 6, negative 6. Here's another example. And if I were to multiply one equation by a constant, I would not get a match. So I'm going to multiply each equation by a number. They're going to be different numbers, so that I can get a match. So if I multiply the top equation by 3 and the bottom equation by 2, my 6's will have a match. So after I multiply them through, I get 6x plus 9y equals 24, and 6x plus 8y equals 8. 6's match, so my x's are eliminated, and then I have 1y equals 16. Now I'm going to plug that back into equation 1 and solve for x, and x equals negative 20. So my answer is negative 20, 16. Again, in this equation, I don't have any matches, so I'm going to multiply each one by a number, and this time it's going to make my y's match, and those will be eliminated. So I get 12x plus 6y equals 30, and 6x plus 6y equals 24. Y's match, and x equals 1. Take this 1 and plug it back into one of my originals, and I get y equals 3, so my answer is 1, 3. Now, in this example, I only have to multiply one equation by a constant, and so I will get 8x plus 2y equals 10, and 8x plus 2y equals 10. These are the exact same equation. They will graph as the same line. So if I continue on and I subtract, I get 0 plus 0 equals 0. That is always true. X and y don't matter in this situation. X and y can be anything. So for every value that I choose for x and every value that I choose for y, it will always work out to be true. So this is infinite solutions. Now for this last one, I have 2x plus 10y equals 14 and x plus 5y equals 12. If I multiply equation 2 by 2, I will get 2x plus 10y equals 14 and 2x plus 10y equals 24. These are almost the same equation. Almost, but not quite. So if I subtract them, I will get 0 plus 0 equals negative 10. That is not true. So 0 never equals negative 10, so we have no solution. These are going to be parallel lines. Parallel lines will never intersect. They will never have a point in common.